Okay, so here's a brief introduction for PySpark. So PySpark is the Python API for Apache Spark, and it allows you to use Python to interact with Spark engine. And PySpark is very powerful. It supports all the major Spark features, including Spark SQL, the DataFrame APIs, structured streaming, and machine learning. And it also has this API called Pandas Spark API, which allows you to scale your Pandas workloads across multiple machines. And PySpark library is super popular. It has over 30 million monthly downloads on PyPy. And you can also see that this is the Stack Overflow trend, and it has been, we have seen a rapid growth in terms of the number of questions asked on Stack Overflow, showing the popularity of PySpark among developers. And also, it's very easy to get started. You can just pip install PySpark, just like any other Python libraries, and then you can start this interactive shell, which will set up a Spark session for you to get started working with Spark right away. So here's an example showing how to execute a SQL query using the PySpark SQL API. And also, it's very easy to use PySpark in Jupyter Notebook for any data analysis or data science work. So you can create a Spark session and use the Spark session to create data frames or load data into this data frame, and then use the PySpark API to analyze your dataset. So one of the most popular features in PySpark is the Python user-defined functions, or UDFs. They are super easy to use. They are very similar to the normal Python UDFs you define in Python, and they allow you to apply any custom transformation or logics that Spark's built-in function cannot handle. And you can also use Python's libraries in these UDFs for more advanced operations. And let's see an example here. So this is an example Python UDF in PySpark. So you can import this UDF function from PySpark and use it to decorate a normal Python function. So here we're just showing a function with one input parameter x. And then you can define the function body of the UDF to have any arbitrary logic and return an integer as we defined in the return type of the UDF. And now you can use this UDF together with the DataFrame API to apply any of your custom transformations. So what's interesting here is that even though the UDF looks pretty simple, the logic to execute the UDF is actually running across multiple nodes in a distributed environment. So this can sometimes make debugging very challenging if there are issues in the UDFs, such as exception being thrown or any performance bottlenecks. So in order to understand UDF better, let's first take a closer look at Spark's architecture here. So Spark is a distributed query processing engine, and there are two main components here, the driver and the executor. So when you run a SQL query or collect a data frame, the driver node will first analyze and optimize the query, and then it will create an executed plan for the data frame. And then it schedules the tasks and distributes these tasks across the worker nodes. And each worker has one or more executors, which are just processes that are responsible for actually running the tasks. And when you use Python UDFs, there are actually several additional steps involved. So first, the driver needs to serialize this Python function so it can be sent over the network to the executors. And since the executors are running in the JVMs, they must first create the separate Python processes to execute this Python UDFs. So the serialized function is then sent from the executor node to the Python worker processes, where the functions are deserialized and executed. So because of this setup, debugging the workloads with Python UDFs can be pretty tricky. So next, we will show you a couple of ways to debug your Python UDFs. So the first tool here is the Spark UI. So the Spark UI is a web interface that provides the insights into the execution of Spark applications. So it displays the details about the tasks, jobs, stages, environments, and resource usage. So here is the executor tabs on the Spark UI, and you can see very detailed information about each executor, including the memory usage, the CPU cores, and task metrics. So for Python UDFs debugging, the logs, the standard out and standard error logs in this tab are particularly useful. So these logs capture the output of the Python worker processes and making it much easier to identify issues with the UDF executions. So here is one simple way to debug your Python UDFs. You can add the print statements in the UDF body to check the function's execution. So when this UDF is executed, the print statement will not show up in the console or the Jupyter Notebook output or in the driver log. Instead, the print statement will appear in the executor logs where you can find them in the Spark UI. So this approach will allow us to track what's happening inside of the UDF on each executor. So just note that debugging this way can produce a lot of logs, especially with larger data sets. So the best way to use the print statement here is when only output the information that you actually need. So for instance, you would like to add an if statement before printing out the log. Okay, now Hyukjin will cover more ways to debug PySpark workloads.
Yeah, thanks, Allison. All right, so we talked about the basic way to use the Spark UI, and then we print things. I mean, that's the usual way I do. But I want to talk about the little bit more advanced stuff because the PySpark itself has a bit of the profiler integration. So for now, we have a two integration. The first thing is the memory profiler integration. And the second one is CPU profiler integration. I'll briefly show how to use and how it works. Before I explain how you use, I want to briefly explain how it works in general first. So Allison talked about the general structure, right? So through the driver send the serialized Python serialized function to the executor, and the executor will launch the Python workers, and the Python worker will execute the Python functions, right? To leverage the profilers, we use something called an accumulator. So whenever we use we execute the Python function here, right? And then we collect the executed information to the accumulator. So basically, you keep the information of the Python workers execution node within the JVM, and then those accumulator result will be combined together to the driver side, and then all results will be combined in driver side and it will be shown to the end user. Meaning that you perform the profilers, then it will show the total execution related information. For instance, it will show the number of the function calls that happen all through the executors. It's not single executors, but through the whole executions. That is how it's implemented right now. All right, I'll talk about the memory profiler first. So this memory profiler is actually a third-party library. So you pip install memory profiler, and then you can perform the memory profile within the local. But as just Allison mentioned, since the execution happens within the worker nodes, that is not my local laptop, but that is in other nodes in my cluster, right? So we need that integration, and the PySpark has the integration with the memory profiler. So to use that, you have to set the configuration code, the spark.sql.pyspark.udf.profiler. And you set the value as memory. And then on the bottom, we have the API called profile. So profile.show with the type memory. Then it will show some beautiful result like this. So here, to properly understand the output of the memory profiler, you have to perform the explain first against your data frame. Then it will show some ID of your UDF execution, and then you can map the ID to the result of the profiler, and you can see the result. So here, bottom, you see for instance, this is my UDF, and it shows which line consumed, how much memory it consumed. This is another profiler I mentioned. So it actually leverages the Python's native profiler that's called the Python cProfile. So it will show which API or which function has called how many times or how much time it took. The same configuration you set to the perf, and then on the bottom you call the profile.show with the perf. Then again it will show the result like this. So again you have to perform the explain API, and then you have to map the ID of the UDF. Then each UDF will show which function, which line of the function has been invoked how many times. It's not only that actually, because there's another third-party library called the frame prof, and then PySpark also itself have a nice integration with that. So you can render the result of the perf provider, and then you can zoom in and zoom out, so you can easily identify the bottleneck, and then you can optimize easily. All right, so that was about the PySpark provider. Let's talk about another one related to the struct trace. So ideally, we should have two struct trace, one from JVM and then one from Python, right? Because as Allison mentioned, the executor is a JVM process, and then to run the Python UDF, you have to launch the Python process, right? So let's say the exception happens within your UDF, then there should be two struct trace, right? One is from Python process, and then one is from JVM. But you execute your UDF, then what you see is that it's just exception from your UDF. It doesn't include any Python workers, internal struct trace, or it doesn't show any JVM struct trace. I mean, you might be interested in that, I'm 100% sure my UDF's right. So there should be an issue in Spark. And you might want to take a look into the Spark, right? So we have the configuration called the simplified traceback. That is enabled by default, but you can disable it. Then you will see the internal Python workers, the struct trace here together. Similarly, you can also enable the JVM struct trace. There's another configuration called the JVM struct trace enable. This is disabled by default. You set this true, and then it will show the JVM related exception too. So in production, you're using your UDF, and then your UDF, my UDF is perfectly fine, but there should be an issue in Spark. And then I encourage you to enable those configuration, and then come to GitHub and then open a PR and then ping me or Allison, then we'll review and hopefully we can make a fix. Yeah. Yeah. All right, so the last one I would like to talk is the IDE and the terminal. I'd like to talk about the overview of the IDE first, because the regular IDE, PyCharm or something, you cannot use it, right, to the PySpark, since, as I mentioned before, the execution happens to worker node. So you need to have a way to somehow remotely debug the worker and executors, right? To do that, you need to launch the remote server. So your IDE, let's say PyCharm in this case that I use here. So you can PyCharm can connect to the remote server, and then you can add the steps and then do the line by line debug. So in overview here, what you need to do is that you need to run the remote server, and then your IDE has to somehow connect to the remote server in your worker node. Thankfully, the PyCharm itself has a bit of little bit advanced, but they have a way to do. So in the PyCharm, you go to the edit configuration and then go to the run debug configuration dialog, and there's a Python debug server. And here, it gives you the instruction of how you install the library for running the remote server. So here, you need to install the PyDev PyCharm this library, but you have to manually go to the worker node and then you have to pip install. And then here, what I'm gonna do is that I'm going to wrap the Python worker, the execution code path. So here, the worker underscore main, that's the original logic of launching the Python workers. And then here above, I'm wrapping that original function with the starting the remote server, so your IDE can connect to this remote server. And then here, the configuration, when I start the PySpark application, in the configuration, I set this, by the way, the demo module is the Python worker, the worker module. So you can replace the Python worker execution path by the remote debug, which is this file, the file name here. So I'm gonna replace the Python worker module, which is a remote debug. So now my Python worker will start the remote server, so your IDE can connect to that. So with this, you start the PySpark application, and then you run in a Spark job. And in the PyCharm, there's a debug button. So you click that, then you can connect to this Python worker running, and then you can do the step-by-step debugging. Okay, last terminal, last but least. I'm sure many of you are very used to how to do the terminal, but I mean, this is the way that I use actually very often, so I'm gonna explain anyway. So in the driver side, since driver side is the Python, standard Python processing in your laptop, for instance, in the client side, so you can just get the PID, and then you can do the regular, terminal, the PS dot or top, and then you can see how much memory you use or how much CPU is using. Similarly, the Python UDF execution happened at the executor node, right? At the worker node with the executors, right? So you have to go to the SSH to the worker node, and then as I just mentioned, the Python worker process is called the PySpark.daemon. So you go to the PSN graph with the PySpark daemon, and it will show all the Python worker process that are running with the PIDs, so you can perform the top, and then you can provide or you can see the memory or CPU usage. All right, summary. So we talked about the Spark UI today, right? So you print out something, but that's not shown in your driver node, but that will be shown in your executor, since the UDF execution actually happened in another node. So you want to print out, that will be shown in your local. You have to go to the Spark UI, and then go to the standard in out, and then you have to check the executor logs. Second, we talked about the Python profilers, where the PySpark has two integration. The first is the memory profiler, the start part library. It will show the line of the code and which line, how much it consumes, which memory. Second, we have the CPU profilers, that's the standard Python profilers. And it will show the elapsed time, so you can identify the bottleneck and then you can optimize. Third, we talked about the stack trace. There should be two stack traces. First is JVM, and then one is the Python process stack trace. They are hidden by default, so they will show the user caused exception by default. But if you're interested in, there are two configurations to turn on those stack traces, and then you can debug further. Last, I talked about the IDE, how to set up the remote debugger. You cannot just use the IDE because, as I mentioned, actual execution happens for the executors. So you have to set the remote debugger, and then we went through how to deal with this terminal. All right, so that's what we all prepared. Oh, yeah, thank you so much for joining.